Hey guys, my name is Mukesh Soni, and I'm here with a small demonstration of how to drive the pump with the Arduino IoT carrier kit, which essentially forms an urban farming kit, and you can make a simple application like automated irrigation system. Now let's have a look at the component. As you can see on the screen here, I have a beaker that has water. The pump is submerged, as you can see here. This is the moisture sensor that is going to detect the moisture level as if it is part of the sensing of moisture in the soil. And if the moisture content goes up, the pump should turn off. This is how it is connected, and it is also shown here on the PowerPoint presentation. Now, there are two ways we can connect the pump. One is using the groove connector to any of this connector which is free. For example, it could be A5 or A6, and utilize two wires out of it, that is 5 volt and the ground wire. Now the 5 volt wire goes to the common of the relay. I'm using the relay 1, as you can see here on the screen as well and in the video. So the 5 volt goes to the relay common, and then the normally open connection, which is the one below this, that goes to the pump, and the ground wire of the pump goes to the ground. Alternatively, if you don't have this kind of groove connector, you can make use of 5 volt and the ground pin on the Arduino for making the same connection. So instead of having this 5 volt coming from the groove connector, any of this groove connector, you can directly connect it to the 5 volt here, which is the first pin on the bottom row on the bottom right corner, and the ground pin that goes to the ground of the pump. This is how I have connected, as you can see here. So I'm using the 5 volt supply and the ground to connect through relay 1 to the pump. Now the moisture sensor is connected to A5, A6. Now let's look at so this is about the connection, and now let's have a look at the software part of it. To initiate this project, you need to create a thing. So for example, I have created MKR02 pump basic demo as thing. And as part of the setup, you want to have 3 variables. Now I have 3 variables. The first one is the pump on, that is meant for the pump control, on and off control. And obviously it has to be a Boolean one. Then I have moisture level, which is analog, which is connected to the analog input. So it has to be an integer value. Now what I'm doing is I'm converting the moisture level, which is the output of this moisture sensor here, which would give 0 to 1023, and I'm converting that value to 0 to 100%. So I'm actually making the moisture level in terms of percentage. There's another variable called pump automation. So this is basically if you want to enable the pump automation, that is automated farming, automated irrigation or not. So if you make the pump automation on, it means the automated irrigation scheme will be on. And what it means is the pump is going to turn on as long as the moisture level detected is less than 20%. So once you have done the setup and obviously associated the MKR Wi-Fi 1010 board, that is this one, and also enable configured the network, you should be good to go. Now let's have a look at the code which is going to control this Arduino IoT carrier-based automated irrigation system. So if I go to Sketch, these are the variables that we created. So integer value of moisture level 0 to 100%. Then we have the Boolean variables pump on, that is on and off of the pump, and the pump automation, whether you want to enable the pump automation or not. When we are using the MKR IoT carrier, so we need to include that library and create an object of that library component. So here we have included the library, and an object called carrier is created from this library. I am also declaring the pin, which is where we have connected the moisture sensor, that is A5. In the setup, we initiate the serial communication, and these are part of the automated code, but we also initiate the carrier library, the carrier object. Now again, this is automated code, but this is the part where we have our code. I am reading the value of the moisture sensor that would go from 0 to 1023, and 1023 corresponds to the highest moisture content. Sorry, the 1023 corresponds to lowest moisture content. So as the moisture level goes up, the resistance decreases, and hence the output of the moisture sensor. So it's inversely proportional. And that is the reason I am mapping the raw moisture level values, which is going to be from 0 to 1023 to 100 to 0. It means when it is completely moist, it will be indicated as 100% moisture level. And if it is completely dry, it will be close to 0. Now, I have a small piece of code here that checks if the pump automation is enabled or not. And if it is enabled, it looks for the moisture level. If it is more than 20%, it will turn off the fan. It will turn off the pump after 5 seconds. So once we turn on the pump, and if the pump automation is enabled, the moisture level will be red. And as the moisture level crosses 20% mark, after 5 seconds, the pump will be turned off. This is part of the Boolean variable, the on pump change. So whenever we have the pump status toggle or pump control toggle on and off, correspondingly, the pump will be turned on and off. So this is irrespective of pump automation enablement. And you can always upload this code. So what I have done is I have uploaded the code. And at the same time, I also created a dashboard. So if I can show you the dashboard, this is the very simple dashboard. We have one button which is going to control the pump on and off. That's why we have a Boolean switch. Then we also have a pump automation Boolean switch to enable the automation or automated irrigation. We are showing the moisture content, moisture level using this circular graph. So as you can see, when the pump is not running, so I'm going to again show you the video. Now you can see the pump is not running. And when the pump is not running, the moisture content, by the way, I have fixed this moisture sensor in such a way that when the pump turns on, it spills water on it and increasing the moisture level as sensed by the sensor. When the pump is not running, there is not enough water or not enough moisture. That's why the moisture content read by the sensor is less. As you can see, it's 2% right now. Now what I'm going to do is, I'm going to just turn on the pump. And at this moment, I'm not going to enable the pump automation. So as you can see, when the pump is turned on, it is continuously running. and the moisture content is more than 2%, and I can switch it off. And as I switch it off, the moisture content again goes back to 2%. Now let's see what happens if the pump automation is enabled. So what we are expecting is when we turn on the pump, the moisture content will go up more than 20%. And the moment that happens, it is going to wait for 5 seconds and then pump will be turned off. So let's see. And that's what happened. There was a delay of 5 seconds, but the percentage moisture content was more than 20%. So this concludes the demonstration where we are working with the automated irrigation system, and all we need is a pump, the IoT carrier kit, and the moisture sensor. So it's a perfect example of a mini system where we have a sensor that is going to take the moisture content, and based on the moisture content level, you can program the Arduino IoT carrier board to toggle or control the pump on and off. I hope you enjoyed this video. Thank you. Thanks for watching.